by popular demand. Welcome, Course 3 students. Oh, I just realized I didn't put this in here. So we're actually doing lesson 4.3, which is all on properties of exponents. And so today we are going to take a look at solving out exponents when I have things like, what if I had 2 squared times 2 to the third? Or what if I'm dividing with those where it's a base and a power and a base and a power. So we're actually, these are some of your exponent rules. I put this little table in here. And we're going to actually talk about these first 3 here. We're going to talk about the product rule today, the quotient rule, as well as the power rule. So let's go ahead into our lesson. All right, so our I can is I can learn to apply the properties of exponents. So as we go on, I think in the past I have used the key ideas page like this where I put most of the information that you're going to need for this lesson, but I wanted to take it one step at a time. So we are going to start by talking about that first rule, which I believe is called the product rule. So we can write that down. So what happens, and it's a little blurry to see, so I might rewrite some of this, but what it says in the word format here is to multiply powers with the same base, keep the base, and add the exponents. So for this example, and I'll rewrite it out, they have 3 to the 5th times 3 to the 8th. What that means then is that to multiply the powers with the same base, keep the base, and add the exponent. So that means my base is going to stay, so this 3 is going to stay. And then I just add the exponents. So what is 5 plus 8? Again, they're still going to stay in that exponent position. So when I actually put this together, I'm going to have 3 to the 13th when I add them all together. So on this side, they just kind of show more of an algebraic way of doing that. But here's an example of what is your product rule. So let's take a couple more looks at a couple more problems here. So I've got, I believe, 4 problems in here. The directions are to multiply. And then something else to be very aware of, again, I told you that sometimes with exponents, our directions can be a little misleading. So this says that I need to write the product as a power. So just like as I finally found the answer here, which is 3 to the 13th, I didn't actually solve what is 3 to the 13th. I just left it in that power form. And so that's what I'm going to do as well. I'm still going to leave it with a base and a power or in that exponential form. So in this case, looks like I have a base of 5, so the base stays, and then I just add the 4 and the 7, or 4 and the 3. I already said it right away. Add them together, 4 plus 3. So then really I have 5 to the 7th, and that's all you need to do. That's your solution. That's your answer. B is just a little different because I have an A, and that's okay. I can have a variable and still solve this out. I can still solve it out because they're both the same variable. So they're both A, so that the base stays the same, and then I just add my exponent. So 12 plus 12. So then I would have A to the 24th, and that's all I need to do. So let's take a look at the next 2. The next 2 are a little more challenging because, at least for C here, what I'm noticing is I've got 16 times 16 to the negative 1. Well, if we were remembering what happens with our negative exponents, we usually make them into a fraction and we bring down that base as well as the exponent to the denominator of that fraction. In this case, we do not need to do that step because, again, the rule was as long as they have the same base, I just add the exponents together. So they both are 16, so that's my base. I can tell that this has an exponent of negative 1, but right now, this one doesn't show an exponent. So what actually happens is every number, if it doesn't have an exponent, it's actually to the power of 1. So this is like saying 16 to the power of 1. Because remember, anything to 0 was 1. Like the whole answer was 1. So this is like saying 16 to the power 1 times 16 to negative 1. So, or sorry, negative 7. So I am taking 1 plus negative 7. So now we have to remember our integer rules. When that happens, when I take a 1 plus a negative 7, it means I'm going backwards into the negative direction, and I'm actually going to end up with negative 6. We, again, don't leave them as negative, so I would rewrite this. You need to rewrite this so that the exponent isn't negative, so I'd have 1 out of 16 to the 6. And it's okay that you leave it in this form. But again, get rid of that negative exponent. And then the last one, I have 4 squared times 3 squared. In this case, based on my rule, the definition of my rule said to multiply powers with the same base. In this case, I have a base of 4 and I have a base of 3. So what happens in this case is this rule does not apply. So what you can write is cannot solve or no solution. I cannot solve it in this form. I mean, ultimately you could solve it and go, okay, 4 times 4 is what? And then times it by 3 times 3. But I'm not going to be able to rewrite it in a power form. Like I can't rewrite it into a form like I had above here. That's going to make sense. Okay, so the next part then is we're talking about the quotient rule. So what happens when I'm taking a base with a power, and I'm dividing by a base and a power? So this one says to divide powers with the same base, keep the base, and subtract the exponent. So they show in here, which again is kind of hard to see, they have, it looks like 6, I have to read it carefully, 6 to the 9th over 6 to the 4th. So how I would solve that is what it really means is that to keep the same base, so both of them have 6, and then I just take the exponents and subtract them. 9 minus 4, so really I have 6 to the 5th. And again, you just leave it in that exponent form, or that exponential form. So let's take a look at a couple of the quotient rules. So these ones I'd already started writing them out, so I think I'm actually going to grab a different color so that you can see the work a little bit better. So in this case, I have 10 to the 8th divided by 10 to the 5th. So my base that is common is 10. I have an 8 and a 5, so I take 8 minus 5. So then my final solution would be 8, 2, and then 8 minus 5 is 3. So I'd have, or sorry, I said 8. 10 to the power of 3. And you keep it in the power form. So I do not want to know actually what 10 to the 3rd is. I just want it in this exponential form. How about your next one? This time it looks like we've got a variable of x, which is fine. We can have a base of a variable, so I'd have x. And then you always take the top minus the bottom. So 4 minus 9. I cannot do the opposite. It's not going to necessarily make it the same version. So 4 minus 9, if I think about my integer rules, would actually give me negative 5. So then I would have to rewrite this by making it a positive power. So I bring that x to the bottom and I make that exponent now a positive 5. And that is your solution for B. So far we've talked about, we've got the product rule as well as the quotient rule. And the last one, and I just want to refresh my brain on the name of it, is called the power rule. So we've talked about how if you multiply two things with the same base, they're going to just add the exponents. If you divide two things with the same base, you're going to subtract them. What happens when you get to the product rule? Or did I say product rule? It's power rule. Sorry. Power rule. It says to raise a power to a power, keep the base, and multiply the exponents. So they give the example, and it's hard to see, of 9 to the power of 4, and then they put in a parentheses, and then it looks like they have a 5. So what it means is they're taking this fourth to the power of 5. This whole value to the power of 5. And so another way we can kind of simplify this is what ends up happening is that I keep the same base, but in this case, I actually take 4 times 5. So in this case, I get 9 to the power of 20. Again, this is going to most likely be shown with those parentheses. So if it was actually something like this instead, 9 times 4, 9 to the 4th times 9 to the 5th, this is going to be your product rule where you add them in. And so in this case, it would be 9 to the 9th. This one is different because it's showing me that those powers are being multiplied by each other. And so this is going to be how I solve this out, and I keep that base, but then the power is going to be different. Let's take a couple problems from there. I think these are the last two anyways. So we're going to take our bases. We're going to use our power rule. So in this case, I got a base of 7. I have a power of 5 as well as a power of 3. We multiply them together. The base still stays 7. I'm not changing the base. I'm just changing the exponent. 5 times 3 is 15. And again, I think as directions tell me, we just leave it as this. I guess it didn't really tell me, but we're just going to leave it in the power form. Same thing with the next one. Base is 8. I have a power of 9 and a power of 11, so I'd have 9 times 11. So then I'd have 8 to the 99th. Obviously, that one's going to be a really large number. If you wanted to throw it in a calculator to see how large it is, it probably is going to give you what's called scientific notation, which we get into later because it's such a large number. All right, last two. My base is 2. I've got then 2 powers that are negative. Oh, so I have to do -7 times -2. Remember, a negative times a negative makes a positive. So -7 times -2 gives me a positive 14. So I'd have 2 to the 14th. And my last one, my base is x, which is fine. Again, I can have a variable being my base. And then it looks like I have 10 and I have -6. So in this case, 10 times -6 would be -60. So I'd have x to the -60. Oh, we ran into a negative exponent, so we're going to actually flip this to the bottom. We're going to have 1 out of x to the 60th. And that's how I would set that one there. So it's simple enough when you get into it. The tricky part is knowing which rule you need to use. Are you using the product rule? Are you using the quotient rule? Or are you using the power rule? Okay, so we will continue on here in class and give you some time to practice those skills. Let me know if you've got any questions.